Jim Malash, and I'm a former tech graduate many years ago. Usually I previously got involved with sound and vibration, but I went through the, engineering mechanics program, so I had a good box of tools that I could apply to most anything. So I've worked for Detroit Edison and Pacific Gas and Electric, and been involved in and out of the energy business. And we, with the last few years, with more emphasis on renewable energy, I've gotten interested, and Alan was, interested in spending some money and getting involved. We've looked at thermal solar and found out that at this point in time, the best deal is to go with the photovoltaic. The technology is at a point where it's, the price is coming down, and the ability to put together a system it's a lot easier than it used to be. Anyway, this will be about the installation on his building at 1104 Data Light, which is up near the Michigan Tech Credit Union. If you park in the credit union parking lot, you can see it. It's an apartment building, and it's got, initially when he had the building built, he had it canted 30 degrees to the east, and that was considered not a good thing. I think some people thought it was a mistake to do that. Well, it turns out that allows a little more exposure to the sun, because now you have a southeast-facing array and a southwest-facing array. So that tends to make it a little more amenable to installation of solar energy. So this is a picture of it. This is the southeast or southwest corner. This thing, I guess, is working here. Yep. So you can see we have the west side is on the left and the south side is on the right side. So we have a total of 36 panels, 22 on the south side, 14 on the west side. And let me just continue. I get ahead of myself. I'm not careful here. Here's another picture. One of the primary considerations was snow buildup. That was the motivation for going vertical. And this is a picture kind of in the middle of the winter, and you can see there's no snow on the panels right now. And that's one of the problems when you have a tilted array is you get a pretty good snow buildup, maybe shuts off the panels for a couple days. And a fair amount of snow on the roof. And the overhang it's a 2-foot overhang, so what falls off, and you get a fair amount of shedding of the snow. It's a metal roof. So we didn't want the panels to be damaged by any snow falling off. So this is a picture of the plot. This is a plot of the. You can see the building itself is 30 degrees. South facing is 30 degrees to the east, and therefore the west would be 30 degrees to the south. So with an array on this side and an array on this side, we get a little bit longer exposure time to the sun. Some of the criteria. Wanted the standard $25,000 for the whole package, and basically the goal was to maximize the solar energy production, whatever we could get, the maximum within that amount of money. We targeted about 10 kilowatts, did some rough calculations, turned out to not be quite that much. Wanted to start off with a grid tie system, where basically you're using the utility as a battery. And then they're measuring the overage that you put in over what you're using, and they give you they don't give you as much as you pay for it. It's about a 2-to-1 factor. If you take the electricity from the grid, you pay 24 cents a kilowatt hour. If you put it in, they only give you 13. So, but at least you're not using it. Minimum maintenance. And that's one of the things I think that's critical is, and it increases the cost, but mainly stainless steel and aluminum hardware on everything. Although Alan's site doesn't have a lot of problems with shade, I think you did have a couple of trees removed. But we wanted a shade tolerant system. And some of the other considerations, the roof mount, we excluded roof mount because it would require additional penetrations in the steel roof. And you'd have to have there was a wind considerations too, because it's kind of windy in that area. You'd have to have a separate superstructure on the roof to support the panels, which increased the cost, and the snow buildup was the main thing. We looked at a freestanding pole mount systems, which are pretty common. Where 2 yards of concrete, an 8-inch diameter steel pole, with 2 to 4 kilowatts mounted on it. They're about $9,000 a piece for those for a good price. So you get basically about $40,000, and there's no room on the lot to really put that many freestanding units. So we in our discussions we just said, well, let's look at a vertical mount.